Hi guys, welcome to the first quiz video, which is over Chapter 1, 1.1 to 1.5 in our textbook. It's over Exponent Rules, and we had a little bit of trouble on the quiz just because it's the first time we've seen it put all together. You might do okay on just identifying your rules when they're in isolation, but when you put them all together, it becomes a little bit tough. So the first couple questions here are about product and quotient rules. And in number 1, you see that we have x to the 5th times x to the 11th times x to the 1st power. So if you start writing these out with 5x's and 11x's and 1x, notice that it's all multiplication in between. You'll be able to see that if we count all those x's up, we can write that as an exponent. So the exponent there is finally x to the 17th power. There are 17 total x's. So don't forget about that first x there. Number 2 is similar, except it has a 3 and a 4, the coefficients in front. So we have basically 2 b's and 4 b's, and it'll give us a total of 6 b's. But with the 3 and the 4, we're actually going to multiply those out. And that's normal multiplication rules. So 3 times 4 actually gives us 12. And with the b's, we'll have still the 6th power there, because we're doing 2 and 4, which is a total of 6. Remember, those 3 and 4s are actually coefficients. So they're actually following the normal multiplication rules. So it's 12, and you can put a dot in between, or you can actually just write it as 12b to the 6th if that's actually better. But either one's fine. And number 3, this is basically what we call it in class, was the distributive property of the exponents, even though it's really not distributing. But that's kind of what it looks like. We have to take that exponent of 2 and make it go to the 6th power, the x to the 3rd, and y there. Oops, I need to erase that there. It's not y squared, it's y and then squared on the outside. So we're going to do 6 to the power of 2, x to the 3rd to the power of 2, and y to the power of 2. And when we do x to the 3rd to the power of 2, that's the multiplication rule. 3 times 2 gives us 6, and I'll show you why here right now. If you write it just like that, there's only one base and 2 exponents, so that's the case where we actually multiply it. 3 times 2 there gives us 6. Oops, hang on. And then I got y squared. So now this is in class where we talked about we need to actually do 6 squared, and 6 squared is not 6 times 2, not 12, it's 6 times 6, which is 36. So the answer is 36, x to the 6th, y squared. On number 4, we're getting a little more complicated. We have to distribute the exponent of 3 to the 2 and the x squared. And then we'll combine it with everything else that we have. So I'll zoom in here to make it a little better. So we'll bring down the 4x to the 4th. And then we have 2 to the 3rd power. And remember, 2 to the 3rd power is really 2 times 2 times 2. And then x to the 2nd to the 3rd. That's one base to 2 exponents. It's the multiplication rule, so we get 6. So now when we do all this here, 2 to the 3rd is 2 times 2 times 2, which is 8. And then x to the 6th. And now this is very similar to the last question, where we'll multiply the coefficients 4 and 8. And then add the exponents 4 and 6. So 4 times 8 is 32, and 4 and 6 exponents, 4 x's and 6 x's, in total is an x to the 10th power there. There's nothing else we can do to simplify that. In number 5, this was probably the most question people got most correctly on the test. And it's probably because it's pretty easy to think about it as exponential form. We have 3 x's on top and 1 on the bottom. So since we have 3 on top and 1 on the bottom, we know we can use our exponents subtraction rule, or just canceling them out. We have 1 on top and 1 on bottom that can cancel. We're left with 2 on top, which is just x squared. You can also put it as x squared over 1 if you like, if that helps you. On number 5, you can also use the subtraction rule right away and just do 3 minus 2, and you know that's x squared right away. Number 6, a little more complicated with 2 different variables and coefficients as well. But if you think about the 4 over 2, Those aren't being raised to powers, they're just numbers that we're going to simplify or reduce. And 4 over 2, that fraction reduces to 2 over 1. So we can draw a fraction bar and write that in there right away for this one. Now you can think about it as 8x is on top and 5x is on the bottom. If you do that subtraction rule, 8 minus 5 gives us 3. And we know it goes on top because if you thought about it being 8x's on top and 5 on the bottom, we have many more, or 3 more, on top than we did on the bottom. If it was reversed and the larger exponent was on the bottom, then our answer would be on the bottom. With the y's, we can do the same thing. We have 3 and 2. There's more on top. 3 minus 2 is 1, so the answer goes on the top there. You can write it as that, or you can just write it as 2x to the third y without over 1. Last one for this section, we have 2 over x to the fourth all squared. And this one we're going to distribute to the 2 and the x to the fourth, to the numerator and denominator. So we get 2 squared over x to the 8th power there. And that's the multiplication rule, 4 times 2. Only thing to simplify this we have to do is 2 squared is 4. So it's 4 over x to the 8th power. In number 8, a rule we learned in class is anything to the 0 power. The significance here is that the parentheses, everything inside those parentheses is going to the 0 power, so it's just 1. Now if I add something to this and put a 3 in front, then the answer would then be 3 times whatever's in parentheses, and that's 3 times 1. So the answer there would be 3 if I changed it a little bit. But the original question, as we had it written down, the answer there is just 1. Number 9, this is the first one where we see negative rules, and in class we learned about a negative exponent can be moved to the other side of a fraction, or top floor or bottom floor of a dorm room like we learned, and hopefully that becomes a positive exponent. So to get rid of this negative exponent, what we have to do is think about it as a fraction over 1, and I like to draw an arrow to move it down. So when we move it down, we're actually not just flip-flopping this fraction, we're just taking what's on top and putting it on the bottom. So the 1's really still down there, but we don't write it. And on top, since everything is gone, we need to put a placeholder of a 1 there. So notice on the bottom it's still positive. On number 10 on the backside, what we're going to do is flip-flop the places here. We're going to flip-flop the m to the negative 7th and the m to the negative 4. We're going to take the negative exponent on the top and move it to the bottom. Take the negative exponent on the bottom and move it to the top. The 3 stays on top because the 3 is not being raised to a negative exponent. The actual exponent of 3 is just 3 to the first, positive 1. So we'll rewrite a new fraction bar here, put the 3 on top. The m to the negative 7 is going to go to the bottom and become negative or positive, and the m to the negative 4 is going to become positive and go up. So bottom going to the top, top went to the bottom, they both became positive exponents. Now with the subtraction rule, 4 take away 7 is 3. And we know that there's actually more m's on the bottom. There's 4 on top and 7 on the bottom. So let me write that out so you can see. 4 on top, 7 on the bottom. And if we cancel off 4 of them, the 3 that are left over are on the bottom, so that's where we have to write them. So the answer is 3 over m to the third power. In number 11, we have a lot more things to do. We have some product rules, we have some quotient rules where we have to add together some exponents, but the first thing we should do is get rid of the negative exponents. So let's move down that negative exponent of negative 3. I'm going to write everything else in red that stays there. So the only difference is this negative 3 is going to go to the bottom. So right now we'll take this x to the negative third and bring it down to the bottom. And on the bottom now it's going to become positive. It's going to be happy. It's going to be a positive exponent. It's 3 on the bottom. And now just look at the fraction and see what else we can combine. You should see on the bottom we can combine the 5 and the 3 to get 8. On the top we can actually multiply 2 and 3 to get 6. So we have 6x to the 6th over x to the 8th power. And then you might say, oh, we're done. But there's actually more. We could take our subtraction rule and do 6 minus 8, because there's 6 x's on top and 8 on the bottom. 6 minus 8 is negative 2, but we know that there's more x's on the bottom, so it's going to be on the bottom. It's 6 over x to the positive 2. Number 12, here we have the fraction 10 over 4, and then y to the 12th over y squared. So with the y's, it's pretty simple there. We do 12 minus 2 and get 10, and we know that that goes right on top because there's more y's on top. And then we think about the fraction 10 over 4. We can divide both of those by 2 since they're even, and we get 5 over 2. And that goes right into our fraction as well. So that's the final answer for number 12. Number 13, this is the time where in first period I didn't actually put this on the quiz, but everyone else should see this, so your numbers might get a little messed up here. But without a fraction bar, this is the reverse of the negative rule basically, where you can take anything that's on the bottom fraction and move it up, no matter if it's positive or negative exponent. The only thing different is the sign will change. So we can bring y to the positive fifth up, but we just have to make it y to the negative fifth on the top. So we'll keep the 6x and multiply it by y to the negative 5 now. And actually that's it. Most of the time in math we don't want negative exponents, but in this set of directions that's okay. This is kind of one of those weird rules that isn't really applied too often, but it could help sometimes. Same thing on 14. We will take the negative fourth power and move it up, become positive 4. But then look what happens. We have x squared and x to the fourth, so we can actually combine those by adding them. So we'll have 10x to the sixth power. Next one, number 15. If we find the missing exponent here, this is the one that actually made a mistake on it first, because I went so fast I wasn't really thinking. But we have to think about whether this is the addition rule or the multiplication rule with the exponents. The 3 is the same in both, so we don't have to worry about that. But then we actually have y to the fifth times some other power of y has to equal a 10th power. So what can we put in that little squiggly there to give us the right answer there? So it's probably either, you're thinking right now, 2 or 5, because times or multiply, or times or add. But here we have to put a 5 in there because 5 plus 5 is 10, since there's 2 bases of y. So in the box goes 5. And the last part here, using tables or number models, I want you to actually explain why y to the fifth squared is w to the 10th. And this one, a lot of us just said it's the multiplication rule because that's what Mr. Luttrell taught us in class, and you'd be right about that. But we did actually do table models of this, where we actually thought of the squared, meaning there are 2 groups of it. And we're going to multiply those 2 groups of w5s, w to the fifth, together. So since we have 2 groups of w to the fifth, we can write out that there are 5 w's in the first group, and then that there are 5 w's in the second group. And if we count out the total number of w's, since we're all multiplying these out loud, we can kind of get rid of the parentheses and not think about it. We have a total of 10 w's. So that explains why the answer is w to the 10th. So thanks for listening. You might need to go back through some of these questions and just practice them again. They can get a lot more complicated, and we'll do some more complicated ones. But just think about how we put all these different exponent rules together. Thanks a lot, guys.